This is the ship's lathe. And as you know, the nature of these machines, they're required to turn material at different RPMs, whatever the MR desires that the piece of material should turn to. So to do that, they use something called a variable frequency drive. The variable frequency drive for this machine is beyond repair. And to save the machine and to save the Navy more than $12,000, I'm going to show you how to install an aftermarket variable frequency drive. To save our lathe, we decided to go with an ACS 888 drive. Now, they sell them at different horsepowers. I think ours was a 30 horsepower one that we bought. Now, what does that equipment do is it really takes shipboard 440 volts and then it converts it into DC and then back to AC, but the frequency changes, and by changing the frequency, then now it's changing the speed of the motor, which is what the old unit used to do. But the old unit, well, it was old, it needed a PLC, it needed the actual inverter, and then all of these components were separate. All of this is one unit now. The main electrical connections are done at the bottom. Okay, so you know all of these things opens and you can see a hole over there where the cables come in, and there it's actually well labeled. All I did is follow this, where I just put the power coming in to L1, L2, L3 as it shows, and then I just hook up the motor just as you see it. Now, I didn't know this at first, but it turns out that the lathes, they had this minus R and plus R, and what it is a resisted bank, and that's what allows the lathe to stop the motor. Even if it's going from high speed, it could stop it within, like, I guess, a couple of seconds because of the resistive load. And all I did is I found the resistive load cables, which it was only 2 cables, and I just put it to minus R and plus R, and it works just fine. After the power connections, then it was the actual controls, and this is printed directly from the tech manual, which I downloaded from the internet, and it told me kind of like what I needed to use to be able to control it. This is the actual terminal board where you make the connections, and you see that everything is just labeled, you know, J, X, and so on and so forth, but everything just follows the same labels over here. See, it has XOR1 and XD02. So I just needed to look at those titles, and then I just went ahead into the connections, and that's how I knew how to reference the different places. So that would be 1, 2, 3, 4 for XOO, or 1, 2, 3, 4 for XD2D. Now, this over here, it was giving me trouble at the beginning, and I called the manufacturer actually to send them an email, and they told me this is to send input to a PLC. So since I'm not using that was great because I didn't have to worry about that. And this over here, it was to create a little panel with indication, you know, to let it know the condition of the machine. So I was like, well, you know what, we don't need that. I talked to the MRs, and they told me we want to see it running, and if it's running, we can tell because it will be rotating. So we don't need silly lie indications to let us know that it is running or not. Okay, so that made things a much more simple. And here, this over here, the bottom, this was to connect it to some sensors to prevent it from over torque. Well, it turns out ours doesn't have over torque, so I didn't have to use that. All I did is I used jumpers between 1 and 3, and just to suffice the same circuit that we have over here. So that was easy too. Alright, so this is the final schematic that I came out with. So I took a screenshot of the computer, and that's how I got this one, and then I opened it with Paint and I edited. So as you can see, pretty simple. Here is where I connected my resisted brake, and that was, like I said, positive and negative, and then the variable frequency drive, I put 440 through it, 3 phases. By putting 440 to it, automatically gives you 24 volts within the system. So it has its own circuitry to be able to do that. And what I'm talking about is here, this 24 volts. Okay, this is supply 24 volts, and you will use it for multiple things. I will go over that in a moment. Another thing that I had that I used, it was the potentiometer. This is how we actually control the speed, and the system only puts 5 volts between this point over here and this point over here, and then the potentiometer, it means that this thing changes, okay, and whatever the position of the potentiometer is going to put a voltage relative to the distance within the AVO. We're doing, between 0 and 5 volts, and that's what's going to determine the speed. So that's what's called the speed reference. Now, I only, even though I had 3 fuses, I only kept 2 because there was no need for the other one. And we did have the Lathe has a 110 step down transformer, and that was great because also it came in with a contactor used for the cooling. So now what I did is that I made it so that whenever you press on or start rather, the contactor energizes and it maintains its contact. But most importantly, I take some of these 24 volts and I put it right here, and see, 24 volts is equal to 1, and then if there is no 24 volts, it's 0. So 0, if I'm not putting 24 volts, there is a stop. Now, if I press the stop or E-stop, emergency stop, then I'm killed the contactor, therefore killing the 24 volts over here, and that's how I stop the machine. So that was that. Now, the machine needs to go forward and backwards, so it does have a lever, okay, that I will show you in a moment, and the lever all the way in one side would be on, and all the way at the other side would be off. So the switches are at the stream. So if I put the switch in reverse, all I'm doing is putting power right here to this little 24 volt relay, which the ICMan, they have them in for the DC consoles. And I need a relay for my neutral. Here it is, that's the relay, and I went ahead and added some wires just for easier connections. I just cut a plexiglass and I just drilled some holes through it. This is gonna be my terminal board, and the connections are as shown. This over here is my schematic of how all the different connections are in the terminal board per se. So to energize the relay, I use this 24 volt power supply, which is already built with the machine, because this used to power the old PLC, but now it's going to power all it's going to power is this little relay whenever we are in reverse. And if the relay is energized, all it does is just close these contacts over here, and by closing those contacts, all I'm doing is putting the 24 volts. See, comes over here, goes in, and now I'm putting 24 volts in this one, which is run enable, and I need to have 24 volts there to be able to run the machine. And the other one comes over here, it goes down and it comes into here, which is the forward. So if 24 volts is equal to 1, and that's equal to reverse. If they take the switch and they put it, the lever in the center, now opens the switch, therefore taking away the 0 volts over here, and the machine stops. And as soon as they put it all the way in the top, which is the forward, then now this contact over here closes, and I'm just gonna, even though I'm using a different color, but it's the same run over here. Now the 24 volts comes up this way, and it goes up here through here, and now I'm putting 24 volts over here, and that the run enable is energized. However, when that is happening, this is open and the relay is not energized no more. What is important about that is that I'm not putting 24 volts here. So now instead of going reverse, this is automatically 0, and the machine will go backwards. As I mentioned before, this over here is the tachometer. The tachometer, all I needed to do is just simply, I was careful to leave 110 applied to it, and the tachometer just works out of the box. After I did all of these, the only thing that I needed to do was just to reprogram the settings and the machine itself using the parameters of the motor. I had to find out the actual van frequency, speed of the motor for 60 hertz, which according to a label plate, I really used the label plate to get a lot of information like amperage, voltage, RPMs, and horsepower. And I had to input all that information via the screen, and I really didn't read the tech manual. All I did is I went to YouTube, I type in the name of the system, which is ASC880, and I type in how to set it up, and then there was a great tutorial by the same company which is showing me what exactly do I need to using those little controls, which you can barely see it down there, but it's just a couple of keys. But with that, I was able to program a lot of the controls to include how fast the machine is supposed to accelerate and decelerate. I didn't have to mess with the potentiometer circuit because that was a circuit on its own. All I needed is power. I believe it was 110 to make sure that it goes to the back of it, and the system, it has its own sensor attached, and it just works. So I didn't make any modifications to that. To label the wires, I just simply use, or the new wires, I just use masking tape, little pen, and then if you want to protect it, you can use clear tape on top of it to protect it. So this is the final product, and as you can see, I got the unit installed, and I used the terminal board to make only a few connections. There is a lot of options that I did not use because we do not need it for this purpose. As down there, those are the connections to the motor, and basically, very simply, power goes into the actual variable controller, variable frequency controller, and then after it gets converted to DC and back to AC, it gets fed there going to the motor. I was able to reuse or repurpose the 24-volt power supply that is available. The step-down transformer still steps down power for the power supply. This contactor over here originally was meant to provide water for lubrication purposes, but the MR says that it's too messy and they did not want it. So that worked out to my advantage because I was able to repurpose that one to wire my stop switch, emergency stop switch. As far as the breakers, I never had to make any new connections. I just left that the way it was, and same thing over there. No major changes, or no changes at all. I did remove a lot of the wires because the new system is much more simple electrically. Here was where the location of the PLC used to be, and over here it used to be, well, the old variable speed controller. The old variable speed controller needed inputs from the PLC. Now this guy, it does everything. It has his own brain and his own set of inverters. Now, as I said before, the coolant no longer applies because the contactor that energized the coolant pump, now I use it is actually to be able to enable my e-stop. If I start the machine, this over here, I gave them the option that this 2 second and 5 second, I program it at the actual unit, and it's just a switch that just provide an input to two different places, and I'll show you in a moment. And I decided 2 seconds and 5 seconds is the acceleration that from the moment that you command the machine to go, like right now I'm gonna go to, well, as you can see, 310. It took 2 seconds to accelerate to that because I have it selected in 2 seconds. Now, by default, this came by 20 seconds, and that one came by to 20 seconds, I believe, too. So I changed it in the program. Another thing that was very important was to be able to make sure that the machine could go forward and backwards. So this is whenever you put it in the center, it's supposed to stop. And notice that it's turning counterclockwise. Now, when I take it to the top, now you notice that the machine goes, well, now clockwise. And all of that is because of this lever. This is the reason why I needed to have that 24 volt relay switch added to the system.